is Chapter 10, Section 3, Operations with Radical Expressions. Our learning objectives are to simplify sums and differences, and sums mean adding, differences mean subtracting, a radical expression, and to simplify products, which is multiplication, and quotients of radical expressions. So we are adding, subtracting, multiplying, and dividing. All four of the biggies today. I cut and paste this from your book, so please start writing here. Like radicals, such as 3 root 5 and 7 root 5, have the same radicand. And unlike radicals, such as 4 root 3 and negative 2 root 2, have different radicands. So if they have the same thing underneath their radical, they are like radicals. If they have different things underneath their radicals, they are unlike radicals. All right, so when we have the same radicand, or if we have a like radical, then we can simplify them together. What I like to think of it as, here's the math on this. If you have an x and it's equal to, if I say x is equal to the square root of 2, then 7x's minus 8x's would be negative 1x. Then you substitute back in the square root of 2. You treat the radical like an x. So if I have 7 root 2's and I'm subtracting 8 root 2's, I end up with negative 1 root 2's. So here, if I have 5 root 5's plus 2 root 5's, how many root 5's does that leave for us? 5 plus 2. So when I have like radicals, I can add or subtract them from each other. The radical stays. It's like an x. It's like a variable. Now, this is the baby step. 1 was the baby step part of it. 2 is a little bit more complicated. 2 takes what we were doing yesterday and asks you to see if you can get similar radicals. Root 7, I know 7's a prime number, so nothing's going to change in there. 28, this is kind of my goal here. I want a 7 underneath the radical. So 28 is 7 times 4. And we learned yesterday that we could separate out the products underneath the radical. So if I have 7 times 4 underneath the radical, that's the same as square root of 7 times the square root of 4. Square root of 4 is 2. So now I have 4 root 7, and I'm going to rewrite this so that the 2's are right next to each other. 2 times 2 is 4. Now I have the same radicals. 4 root 7's plus 2 root 7's is 8 root 7's. All right, let's try this here. I always, if I have an even number, I always go for the cut. Let's cut it in half and see what happens first. So if I have 32, and I'm going to cut it in half, what's half of 32? 16. And if I have 18, and I cut it in half, that would be 9. So 18 is 9 times 2, and 32 is 2 times 16. So now I can do the same thing that I did over here, and I go 5 times root 2 times square root of 16 minus 4 times root 2 times root 9. Simplify these out. 5 times 2 times 4, because the square root of 16 is 4. And then 4 times root 2 times 3. Now let's shuffle. We got 5 times 4 times root 2, 4 times 3 times root 2. And now I can multiply these together. 20 root 2's minus 12 root 2's give us 8 root 2's. All right, so now we're going to start multiplying. All right, because remember we just did sum and difference, which is adding and subtracting. The other part of our learning objective is multiplying and dividing. So in this case, we are multiplying, and we're going to end up distributing. And I'm going to rock out FOIL because FOIL is my faves. But we're going to end up distributing and then simplifying our radicals. So in this case, I have root 2 times root 6 plus root 2 times 5. And where I have radicals, I'm going to combine them underneath one radical. This is root 12. And then when I'm writing radicals in numbers, I always want to write the number first and the radical second. Let me back this up one step, because I kind of fast forwarded through that, and that's not fair to you guys. So this is, I combine these underneath one radical, so I have square root of 2 times 6. 2 times 6 is 12. We need to simplify 12, though. We worked on a whole section of this chapter with simplifying radicals, so we're going to simplify it. But 2 times 6, neither perfect square lives in either one of those. So let's do 4 times 3, because I know 4 is a perfect square. So this is square root of 4 times the square root of 3 plus 5 root 2. And square root of 4 is 2, so I've got 2 square root of 3 plus 5 square root of 2. Two different radicals, cannot combine them together, so we are done. All right, next item up for bid. Square root of 11 minus 2, quantity squared. That's the same as square root 11 minus 2 times the square root of 11 minus 2. And I'm going to FOIL, FOIL, FOIL. Square root of 11 times the square root of 11 minus 2 times the square root of 11 minus 2 times the square root of 11. Plus, because it's negative times a negative, 2 times 2, which is 4. I'm going to combine my like terms together, and I'm going to simplify this guy right here. We write this as square root of 11 times 11, which is the square root of 121, which is, crazy enough, 11. Minus negative 2 square root of 11 minus 2 more square roots 11 is 4 square root of 11. And I got plus 4 hanging out here. We are going to combine 11 plus 4, which is 15, minus 4 root 11. 15 doesn't have a root, so he can't combine with minus 4 root 11, and we are all the way simplified. All right, I'll show you one more. So I have to erase B. Okay. So I'm going to FOIL this out. I'm going to have 4 root 3 times root 6. I'm going to have 3 root 6 times root 6. I'm going to have minus 2 root 3 times 4 root 3 and minus 2 root 3 times 3 root 6. Okay, so I'm going to put all my roots underneath one radical and see where life takes me there. So in this case, I've got 4 square root of 3 times 6 is 18. And then I have 3 square root of 6 times 6 is 36. And I have 2 times 4 is 8. Square root of 3 times 3 is 9. Minus 2 times 3 is 6. And then 3 and 6 is 8. Boom! Okay. So let's simplify what we can. This is 4 square root of 2 times 9. This is 3 times 6. This is 8 times 3. You guys seeing how this is? Square root of 36 is 6. Square root of 9 is 3. And this is also 2 times 9. All right. So now I've got 4 root 2 times root 9 plus 18 minus 24 minus 6 root 2 times root 9. This is 4 root 2 times 3, because square root of 9 is 3, plus 18 minus 24 is a minus 6. Because 24 minus 18 is 6, and since 24 is the negative 1, 6 gets to be negative. This is 6 times root 2 times 3. Almost done. 4 times 3 is 12. 6 times 3 is 18. And then I've got 12 root 2's minus 18 root 2's, which gives us negative 6 root 2. So let me write that as negative 6 minus 6 root 2. And I got the negative 6. And then see you. That was almost a heart attack. All right, I want to take a moment and talk about conjugates. So the conjugates are the sum and difference of the same two terms. For example, 7 plus root 3 and 7 minus root 3 are conjugates. The product of conjugates, so when we multiply them together, is the difference of squares. For example, when I multiply my square root of 7 plus square root of 3 times square root of 7 minus the square root of 3, it's the difference of squares that we did previously. So that's equal to square root of 7 squared and square root of 3 squared, which is just 7 minus 3. And what I like is that the product of conjugates has no radicals. When a question asks you to simplify, one of the things you need to make sure of is that there are no radicals in the denominator. And the way we are going to eradicate radicals is by multiplying by the conjugates. So we are going to take, when it's asking us what is a simplified form of negative 3 over root 10 plus root 5, we're going to take that And we're going to multiply the top and the bottom by the conjugate. As long as we do it to the top and the bottom, we're sames. Life is good. So just remember, when you're multiplying a fraction, you multiply the tops together. And you multiply the bottoms together. We're going to use the difference of squares to simplify our problem for us a little bit easier. So this is going to be the square root of 10 squared minus square root of 5 squared. So if I rewrite that, it's negative 3 root 10 minus, negative and negative give you plus, so I'm just distributing it out. Negative 3 and negative root 5 gives us positive 3 root 5. And on the bottom, I get square root of 10 squared is 10. Square root of 5 squared is 5. So this is negative 3 root 10 plus 3 root 5 divided by 10 minus 5. Boom, I am simplified because I no longer have radicals in the denominator. One more topic before we can be happy today. Golden rectangles appear frequently in nature. Golden rectangles. The ratio of length to width of a golden rectangle is 1 plus root 5 to 2. For our problem here, our golden rectangle is 12 inches long, so our length is 12 inches. What is the width of the rectangle? We don't know the width. So a ratio usually implies a fraction. So length to width for this scenario is 12 over x. And in the above, it says the length to width of the golden rectangle is 1 plus root 5 over 2. So this is how I like to solve problems like this. So if you look, here is our real problem. Length to width is 12 over x equals 1 plus root 5 over 2. I'm just going to cross multiply. So I've got 12 times 2 is 24. And x times 1 plus root 5. I'm actually solving for x, so I have to divide both sides by 1 plus root 5. Now, if I want to write this, write your answer in simplified form. So I'm looking at the directions. We want to make sure we always follow that. Simplified radical form means I can't have any roots in the denominator, so I'm going to have to multiply by the conjugate. And then we're going to throw it into our calculator and get a decimal approximation. So if I want to write this in simplified radical form, I multiply by the conjugate. And I get 24 times 1 minus root 5 divided by 1 squared minus root 5 squared. Almost done, I promise. So this is 24 minus 24 root 5 divided by 1 squared is 1, minus square root of 5 squared is 5. So this is 24 minus 24 root 5 over negative 4. And 4 goes into everything. So if I rewrote this as I can see that 24 divided by negative 4 will give me negative 6. So 4 goes into 24 6 times, and 4 goes into 4 1 time, and there's a negative, so the negative 6 over 1 becomes negative 6. Alright, so that's our simplified, actually let's multiply it out and we'll get the simplified form. There's our simplified form. Now we have to calculator chug-a-lug, which is piece of cake calculator. So we've got 6 times the square root of 5 equals plus 6 negative. So it's 7, round to the nearest tenth. So 7.4.